So now let's look at this example here. This example has tin reacting with silver to produce tin and silver. So we have one atom of tin, one atom of tin, one atom of silver, and one atom of silver. So it appears balanced from a mass standpoint, but if we look at the charges, we know it's not balanced because we have a total of +2 over here, and we have a total of +1 charge on that side. So it's not balanced. So we need to balance it. So first we write our individual, we separate our species and write our two half reactions. So we have SN2+ going to SN, Ag going to Ag+, and now I need to figure out where do my electrons need to go. So if I add electrons here, +2 electrons, and I chose 2 because of the charge, 2+ + 2- gives me a total charge of 0, and the charge over here is 0, so I'm balanced. Here, I know that I'm probably going to need to add my electrons to the other side because once again, they're added to one side and then the other. It's a pair. So over here, I'm going to only add 1 electron. Because of the fact that it's +1, I needed 1. So now I look at this and I first said, okay, I already balanced my atoms. My electrons, they're not balanced because I have a 2 and a 1. So I can't just put a line through both of them and move on. I have to balance them. And how I balance them is my lowest common multiple. Meaning, if I multiply this whole equation by 1 and multiply this equation by 2, now I can have the same number of electrons being transferred across the two half reactions. So this will stay the same. Here I need to multiply everything by 2. That 2 has to go to every species, including the electrons. Okay? So now my electrons cancel, and now I add them together, and I have a balanced chemical equation. So when I'm all finished, this is what it should look like. Tin2+ aqueous plus 2 silvers solid yields 10 solid plus 2 silvers as a solid. Alright, here's the next equation we're going to do. Once again, note it's not balanced as far as charge goes. It's not even balanced as far as atoms goes. Okay, that's a really good thing to note right here. I have 2 iodines and 1 iodine over here. Not balanced. +4 on this side, +2 on this side. Not balanced. So let's write the half reactions. So here are my half reactions. I first suggest you start by balancing the atoms. It'll save you so much error. Okay? So in order to balance them, we can put a 2 in front of this iodine, and now I have 2 iodines, I'm good. So now I need to figure out what side do I put my electrons on. I put them on the side with a greater positive charge. Okay? So now I have a total of +2 over here, +2 over here. My iron is balanced. Over here, 2 negative, 0. So +2 electrons. I hope at this moment now you're thinking my electrons are not balanced. So I need to multiply one of them by 2. Okay, so this becomes 2 + 2 + 2. And now I can cancel out my electrons and add the whole equation together. So in the end, you should have 2 Fe3+ aqueous plus 2 I- aqueous yields 2 Fe2+ aqueous plus I2 as a gas. So this is kind of the whole process. Sometimes you might want to do a 2 and a 3 or a 5 or a 1, I don't know. But you just multiply it by whatever numbers you do, you need to make these electrons cancel out.